we're going to continue our discussion on nuclear chemistry, and specifically we're going to be talking about beta decay for the purposes of this video. So again, anytime you're going through some sort of radioactive decay, it's because whatever element you're dealing with, it is unstable for some reason. In this case, beta decay, and there's your little Greek letter beta for that, this is when a neutron transforms into a proton and an electron, or a beta particle, is emitted. So it sounds a little crazy, but neutrons will transform into protons in this particular case. This example right here, we're dealing with something called carbon-14. You've probably heard of that. They use a lot of carbon-14 for dating really ancient biological material. So it's a really cool thing to think about for the purposes of this video. So this carbon-14 will go through radioactive decay. It'll specifically go through beta decay. So we're going to start with what we've done before. We're going to count our protons and neutrons to figure out what's happening in this process. So that atomic number right there, that number 6 atomic number, also gives us our number of protons. So that's pretty straightforward. We have 6 protons on the left-hand side. Notice that we also have our mass number at the top left, that 14. That mass number tells us how many protons and neutrons we have added together. Since we already know the number of protons we have, we could take our mass number, which is 14, minus the number of protons to get our number of neutrons, which is 8. Remember, we said that during beta decay, a neutron will transform into a proton. So we're getting an extra proton through this process. So we had 6 protons before, now we are going to have 7. And where we had 8 neutrons before, we now have 1 less because it's being converted into a proton. So we have 7 for neutrons. All right, so what does that leave us with for isotope notation? Notice for our mass number, we still have protons plus neutrons. That still equals 14. So 14 will go up here. And then our number of protons, which gives us our atomic number, is 7. Now because we changed our atomic number, we're no longer dealing with this carbon right here, which has an atomic number of 6. We're actually now dealing with its neighbor, nitrogen, with an atomic number of 7. So I'm going to write my letter N, and then we have to write what it gives off. We said that an electron is emitted. People also call it a beta particle because this is beta decay. The way we write it based on the way your reference sheet provides it for you, we have our electron symbol, just a lowercase e, and then a 0 and a -1. If it helps you remember, notice that 14 is not changing at the top, so 0 for 0 change. Notice we went from a carbon with a atomic number of 6 to an atomic number of 7, so just to balance that out, put a -1 next to that electron. That should help you remember that. And then just like before, if you can do this in the forward direction, you can also do this in the backwards direction. If I give you what's on the right-hand side of the arrow, you should be able to backtrack by counting those protons and neutrons to get what you started with on the left-hand side. Take a second, pause, take any notes you need, and then you will get started on answering your own questions.